This is Vibe, our STEM project. I am Alexander.
I am Ángel Mauricio.
I am Mauro.
I am Josué.
I am Franco.
I am David.
Well, currently the world is facing a global energy crisis and a serious environmental problem caused by the excessive use of resources. Urban environments are full of constant noises and vibrations that are also a type of pollution that affect human health and are generated through traffic, construction, and industries. Instead of letting this energy go to waste, our main goal is to capture these noises and vibrations to convert them into electrical energy. And store it or use to power electronic systems such as street lights. This project is directly related to SDG 7, affordable and clean energy, and SDG 11, that focus on sustainable energy, sustainable cities and communities.
In our theoretical framework, the global energy crisis, as it was said before, is a problem that is very much, is already worked on. But it is linked to fossil fuel, and there is already a lot of solutions that involve clean energy, like solar panels and very efficient ones. The definition of key concepts and the keywords are renewable energy, nanotechnology, and storage. Renewable energy, we already know, is energy that can be produced without making that much waste and can be replicated a lot of times. Nanotechnology is the application of nanoscale science to improve energy conversion and efficiency. In energy storage, is devices such as batteries and supercapacitors, most made of lithium. The OLEDs and LEDs are the organic light emitting that we use in today's lives. Now we have piezoelectric effect, friction-based energy, and IoT. The piezoelectric effect is the conversion of mechanical energy into electrical energy. The friction-based energy is the use of mechanical motion to generate heat or electricity. And the IoT is the network devices that enable smart control of energy systems.
Okay, very good. Now I understand many concepts, very basic. Okay?
There are a lot of relevant theories and that are very important for this topic. The first one is heat transfer. This theory explains how nanostructures enhance biofuel efficiency. The electrochemical theory, this covers the performance of batteries and supercapacitors for storage. The optical scattering and Snell's law, explaining how light can be more efficiently extracted from LEDs. The plant photobiology, that describes the spectral properties of light and regulating plant work. The photobiology. Photobiology, sorry. Describes the spectral properties of light regulating plant work. And tribology, friction and friction mechanics, the theoretical foundation for friction-based energy exchange. We review different significant studies of particles like nanotechnology, solar carrying, and biofuel energy, production energy by producing and enhancing material efficiency. The advanced material research that shows how nanostructure hybridization boosts performance. The OLED studies confirm scattering films can increase light extraction efficiency by up to 22%. The LED-based plant tissue culture studies demonstrate how the spectral toning regulates photosynthesis and growth. And that's about the important ones. Now, lastly, in the theoretical framework, we have the connection to research question. These technologies raise a central question, which is how can renewable energy harvesting coupled with advanced storage and smart lighting create a sustainable and self-efficient lighting system that can adapt to different urban environments? That's the question. The explanation of how this proposal is different from current solutions is that there are five differences. The first, that this proposal is different because it integrates multiple energy sources, the piezoelectric and nano. It includes smart storage, supercapacitors with advanced materials, the intelligent control, IoT for real-time monitoring, and the cross-disciplinary application, extending the efficient lighting vision beyond streets to agriculture and industrial uses.
Okay, I know there are a lot of concepts, it's difficult to memorize them, but at least just try to not avoid reading too much, okay? Thank you.
Next page.
I already clicked on it.
Well, so it is the chemical systems. The chemical systems is the process to release vibration in place in rechargeable batteries. So it is functionally so easy. The vibrations in the environment are like a sound, and here, like our team is produced, is the vibrations are gonna change into chemical energy, and the chemical energy will transform to electrical energy into the rechargeable batteries, and they generate light or electricity. So this I make it possible to quantify how many pollution in this is with some battery, and we change the battery that us produce and another battery that produce, and this how the pollutant can be stored, and how much electricity we store is come with the Fahrenheit law. The chemical equation that we use is CO2 plus 8Q plus E2E is CUS. So the electricity generated by the sensor reduces the copper ions, CO2, present in the electronic solution. So the energy that we produce is the CO2. The ions gain electrons are deposited as a metallic copper. The metallic copper that here is in the form is the particle, the batteries rechargeable. And in this way, the electrical energy is converted into chemical energy stored inside the copper cell. And during this discharging, the metallic copper is outside, releasing electrons from through the external circuit. That means that the copper is also can be outside, and this we a problem that the external circuit, and this electron power LED lamp transforming the chemical energy back into electrical and light energy.
So, can you?
That's it. You want me to move to the next one? Okay. I am in another slide from running the computer, the blueprint. I'm in blueprint and you are in. Let me. Yeah. Okay.
So for a blueprint,
I need to see how can I.
the original design was made in Thinkerprep. The design is purpose so the real product can be placed in cities, can be placed like along streets and places where there is no choice. So it is designed to maintain a fashionable way to put
Okay.
it in public spaces, and that it doesn't take that much space. The box on its right side is the battery. It can indicate how many charges in it, and this is made so for powering street lights. It is not made for powering a lot of like big power consuming lights. So it is not made to produce that much energy.
No, as any of the scales, these are prototypes. If you were to make it in a bigger scale, it would be super costly to do it.
Yeah.
So, I understand perfectly.
That's the representation of the bright image. That's
Oh, okay.
what is connected to the.
Okay, with the prototype, it has four main parts. That is the protoboard, the sensors, that is a vibration sensor, the LED light, and the empty 9-volt battery of copper. It consists of, the materials of the prototype is some wires, coppers, solder, and some plastics like the protoboard. The measurements approximately is the protoboard with 10 centimeters to 15 centimeters, the sensor of 5 centimeters, the battery of
8 centimeters and 2.5, and the LED light of 1 centimeter each part. Then with the functionality of the prototype,
Okay, you want me to do another one, sorry. I was taking for my dog. 50 pesos. 651.
okay, our prototype uses a vibration sensor capable of detect the movement within a range of 5 centimeters to 1 meter. It can the triggered energy can pass to the sensor to the battery, and the battery turns on the LED light.
Whenever you want to
Yes.
start.
So we have a variable table, and we'll go over most of these. There being two very important variables. So first, there's vibration amplitude and vibration frequency. Vibration frequency measured in hertz and vibration amplitude measured in meters per second. Then we have pitch terms, which is measured in decibels. Vehicle speed, which may sound a little random, but it's mostly to know how high can the sound go when our prototype is on working. Instantaneous electrical generation, which is measured in watts, energy spent and stored energy, both being insanely important. And the most important one, energy delivered to streetlight, which is the one that works mostly with our project, because our project uses sound to know the energy, or to capture the energy to then use to streetlights or to store it. Which is why stored energy and energy delivered are two of the most important variables. Now, these variables help us predict and know how well our project is functioning in a street, to know if we have to change it to another street or to keep it there. That's it.
The measurement plan. What measurements will be taken in the future? We will be measuring variation amplitude and frequency, acoustic level, voltage, current, and power generated by the harvester, and the energy stored and transferred to the streetlight. How will we calculate the variables? Energy per event, we will calculate the integration of voltage and current over time. Stored energy will be battery voltage versus capacity curve, and efficiency, useful energy delivered over estimated vibrational energy. What will the information be used for? To determine how much energy each vehicle will contribute to the system, to evaluate if the system can reliably power a streetlight for a significant period of time, to optimize placement of sensors for maximum efficiency, and to verify whether the system can scale up for multiple streetlights. Next week. And our conclusion. In conclusion, this proposal presents an innovative approach to addressing urban noise pollution by transforming it into a variable source of renewable energy. By capturing sound and vibration produced by traffic and other urban activities, the device can generate and store electrical energy to produce lighting systems, particularly during emergencies or to reduce waste.
Very good. Okay. Okay. Thank you very much, guys. Let's give my beautiful children. Thank you. Let me just stop.